Today's lesson is on page 303 in your red book. We're going to learn another way to divide a polynomial by a binomial, and this is using a process called synthetic division. Yesterday, you learned how to divide a polynomial by a binomial using the process of long division. And just as a really quick review from yesterday, if you were to divide this polynomial, 3x cubed minus 7x minus 9, by x minus 2, you would put your x minus 2 here, and this is your divisor. You put your polynomial that is being divided here under the dividing sign. So this is your polynomial, this would be p. Your quotient is your answer, and your remainder, of course, is your remainder that you're left with at the bottom after you've done all your dividing. The process today that we're going to look at is synthetic division, and the example below in your book here shows the exact same question done with synthetic division. Now, some people use synthetic division because it's a little bit quicker. It works in most cases, and some students just prefer this method over long division. We'll learn both of them, and you can decide which method you prefer. If you have a really close look at this, you can see some similarities. In this case, this 2 is your divisor, just like this x minus 2 is your divisor when you were long dividing. You can see here 3, 0, negative 7, negative 9 actually correspond to the coefficients 3, 0, negative 7, negative 9 in your polynomial that you're dividing. Okay, the only thing that is missing are your x terms. And these numbers here, 3, 6, 5, correspond to the coefficients in your quotient, 3, 6, 5. This one that is circled here, or when we do it, we're going to put it in a box, this is your remainder. Okay, so this system of synthetic division, in this case, this would be your polynomial. This 3, 6, 5 would be your quotient, your answer, and this 1 is your remainder. All right, so let's turn the page and we'll just have a look at how this process works. It's really quite simple. Once you do a few of them, you'll catch on really quickly, I think. We're dividing a polynomial 2x cubed minus 3x squared minus 8x plus 15, and we're dividing it by x minus 1. Okay, so the first thing you would do is you would take this x minus 1, that's your divisor, and you would set it equal to 0. If x minus 1 equals 0, then x equals 1, okay? And that's what you put right there, just the 1 part. Then you take your polynomial and you look at just the coefficients of each term, and you have to, first of all, make sure that it is in descending order by power. And if there is a power missing, for instance, this one there isn't because you have x cubed, x squared, x, and then x to the 0, which is 1. So there is no x term missing. If there was, you would put in a 0x to the whatever power was missing, just as a placeholder. But in this case, we don't have to worry about that. I'll show you some where we would. Okay, and what you do is you just take that coefficient, the number in front of the x, and you write them here. So we've got 2, negative 3, negative 8, and 15. Now, when we were dividing by long division, we had put a negative sign out front here to show what operation we were doing. This time we're actually going to be adding, so we'll put an add sign out front. Okay. Now, the first step is we bring down this first term 2, and we write it down here. I like to keep a box here because this last term will be our remainder. Okay, so I bring down the 2, then I multiply this 2 by the 1 that's out front. So 2 times 1 is 2, and I put that answer right here. Okay. Then I add down the column. So negative 3 plus 2 is negative 1. Okay. Then I take this negative 1 and I multiply it again by my divisor out front, the 1. So negative 1 times 1 is negative 1. Then again I add down the column. So negative 8 plus negative 1 is negative 9. Then again I multiply that negative 9 by the 1 out front. Negative 9 times 1 is negative 9. Then one more time I add down the column. So 15 plus negative 9 is 6. So that's my remainder of 6. So as you can see, each time I bring a number down, it's kind of this kind of a pattern, isn't it? Okay. Now, in this particular question, it's asked us to express this answer in the form of our polynomial over our divisor equal to our quotient plus the remainder over the divisor. Okay, so we better identify what those parts are in this equation. Okay, so if you remember this 2, negative 3, negative 8, 15, that's the original polynomial you started with. Let's label it P, just so that we don't get mixed up. Our answer, when we divide, the answer is called the quotient. Okay, so that is, well, maybe let's write it on this other side so that we don't get it mixed up with our remainder. So our quotient is this part here. Okay, this is our remainder, and this number out front here, this was our divisor. Okay, but keeping in mind that our actual divisor was x minus 1. Okay, that whole part. Okay, so now we're going to write this, the P over the D. So now our polynomial is 2, but it's x cubed, minus 3x squared. We're actually going right back to the original form, right? So we're going to write 2x cubed minus 3x squared minus 8x plus 15 all over the divisor. Divisor was x minus 1 is equal to the quotient. That's our answer. But now we have to look at this carefully because this 9, this is going to be our constant term, and then it'll go up in ascending order. So this will be our x term. This will be our x squared term. So this is really 2x squared minus 1x, which is minus x, minus 9. And then that's plus the remainder, which was 6, over the divisor, which was x minus 1. So this is how they want us to list our answer. This whole thing would be our answer. Okay, let's try class example number 2. Consider the polynomial 5x to the 5th minus 6x to the 4th plus 3x squared minus 2x plus 1. And it asks us to use synthetic division. Now, what I do notice when I look at this one, and I have to check this every single time, first off, is the exponents, are they going in descending order by power? So I've got the 5th power, 4th. I'm missing the 3rd power right here, right in between the 4th and the 2nd. So I'm going to have to put in a placeholder for that. Okay, so I'm going to put in my exponent, the coefficients of the x terms. So I've got 5, negative 6. Then I have to remember that there's going to be a 0 because I have 0x cubed term. So I'm just going to maybe move this down a little bit. I've got it a little too squishy. Okay, so we're going to have 5, we're going to have negative 6, we're going to have a 0, we're going to have a 3, a 2, and a 1. Oops, that 2 is a negative 2. Okay, then we're going to draw this, leaving room for one more row underneath each of those numbers. Okay, The number that I put out front here, my divisor, I'm going to get from setting this divisor equal to 0. So if x plus 2 equals 0, then x is negative 2. Okay. So it's the negative 2 that I'm going to put out front here. Okay. Then, step by step, I'll remember to put my box here because that's where my remainder will be at that last spot, and I don't want to forget that. Okay, so then I just break down my 5. Now I'm going to multiply this 5 times this negative 2 out front. 5 times negative 2 is negative 10. Then I'm going to add. Remember, we're adding now down the columns. So negative 6 plus negative 10 is negative 16. Then I multiply that, negative 16 times this negative 2 out front. So negative 16 times negative 2 is negative 32. Then I add, positive 32. Then I add 0 plus 32 is 32. Then I'm going to multiply 32 times negative 2, which is negative 64. Then I'm going to add down my column. 3 plus negative 64 is negative 61. Then I'm going to multiply that by negative 2 out front, and I'm going to get 122. Then I'm going to add down the column. Negative 2 plus 122 is 120. Then I'm going to multiply that by the negative 2 out front, and that is negative 240. And then finally I'm going to add down my column. 1 plus negative 240 is negative 239. Okay, so my quotient would be, and I have to remember that this will be my constant, so then this will be x squared, x cubed, x to the 4th. So my quotient is 5x to the 4th minus 16x cubed plus 32x squared minus 61x plus 120. And my remainder, so this is my quotient, and my remainder is negative 239. All right. B says now, find the value of the polynomial when x is replaced by negative 2. Okay, so I'm going to take now my quotient, or sorry, not my quotient, go back to the actual polynomial here, and everywhere where there's an x, I'm just going to plug in a negative 2. So I've got 5 times negative 2 to the 5th minus 6 times negative 2 to the 4th plus 3 times negative 2 squared minus 2 times negative 2 plus 1. So this is actually going to be 5 times negative 2 to the 5th is negative 32 minus 6 times 16 plus 3 times 4 plus 4 plus 1. And the grand total is negative 239. And when I do that, I notice that the remainder, when I divided by x plus 2, when that was my divisor, it's the same as the value of the polynomial if I put my negative 2, this number, right back into the polynomial. So we'll write that. The remainder, when dividing by x plus 2, is the same as the value when x is replaced by negative 2. Class example number 3. If x plus 3 is the divisor in the following synthetic division, calculate some missing values, m and p. Okay, so we would just put x plus 3 equal to 0. So really that means x would be negative 3. Okay, so we put a negative 3 out here. Okay, we're going to bring down the 2. It's been done. 2 is going to be multiplied by negative 3. That'll give me negative 6. Then I add down the column 2 plus negative 6 is negative 4. Then I multiply negative 4 times negative 3. That's going to give me positive 12. Negative m plus 12 must give me 2m. And 2m times negative 3 must give me n. And then 16 minus n must give me p. Okay? So what I know is that if I take this column here, I can figure this out. Negative m plus 12 would give me 2m. Okay, so then I just use regular algebra to solve for m. So I'm going to add 1m to this side and add 1m to this side. So I've got 3m equals 12. So m equals 4. Then I also know that this n here is determined by multiplying this 2m times this negative 3, right? So n is 2m times negative 3. Okay, well now I know what m is, so n is 2 times 4 times negative 3. So that means my n must be negative 24. And then finally I know that 16 minus that, or sorry, 16 plus that n would give me this p. Okay, so p is 16 plus n, and I now know that my n is negative 24. So p is 16 plus negative 24, negative 8. So I have figured out what my m and what my p are. I had to figure out n to make that happen, but it just asked me to tell what m and p are. All right, flip over the page. We'll have a look at class example number 4. When 2x cubed minus 4x squared plus ax plus 3 is divided by x plus 2, the remainder is 3. Determine the value of a. Okay, well, let's set this up. First of all, x plus 2 equals 0, so x equals negative 2. Okay, so when we set this up, I'm just checking to make sure I have descending powers. So I've got x squared, x cubed, x squared, x. Yes, we're good. Okay, so I'm going to have 2, negative 4. A is what we don't know, so we'll put it as a, and 3. Okay, same as before. Set this up, leaving yourself a column underneath. And we've got negative 2 out front. We're going to bring down 2. Then we times 2 by that negative 2, that's negative 4. Negative 4 plus negative 4 is negative 8. Negative 8 times negative 2 is positive 16. A plus 16 is the answer here, so we'll just put it as a plus 16. Then a plus 16 times negative 2 is going to be negative 2a minus 32. And when we subtract, or sorry, when we add, we've got 3 plus negative 2a minus 32. So that's negative 2a minus 29 as our remainder. Okay? Now, it does tell us that the remainder is 3. So if this is our remainder, negative 2a minus 29, then that must equal 3. So then I just solve using regular algebra. So negative 2a equals, I'm adding 29 to both sides, 32. And so a is negative 16. Okay, now the next section is just a little bit different because up until now our divisor has been just x plus or minus something. This time we have a divisor that has 2x or 3x or some number in front of the x, a coefficient of x. But nothing changes. We do it the exact same way as before. So in this case, we're going to take 2x minus 1, set that equal to 0, solve for x. So we're going to have 2x equals 1. So x is equal to a half. Okay. Then you just set your question up exactly like before. So you've got your half out here. We've already got the coefficients of x filled in. We'll just check and make sure we have descending order of powers, and we do, so we're okay. We don't have to put a placeholder in there. And then you do it exactly the same. So bring down your 2, multiply it by a half. 2 times a half is 1, and 1 plus 1 is 2. 2 times a half is 1 again. 5 plus 1 is 6. 6 times a half is 3. Negative 1 plus 3 is 2. Okay? So the quotient in this case, remember this is my constant, so this is x squared. So we've got 2 or no, sorry, I'm getting ahead of myself here. So because this kind of a question is different than the others that just were an x term, there was no coefficient of x here, this one is a little different. Because we have actually divided it by a half, we have to realize that this 2x minus 1 is actually 2 times x minus a half. If you multiply this out, 2x, and then 2 times negative a half is negative 1. So it's actually twice x minus a half. So in essence, what we've done is we really have divided first by x minus a half, where then x equals a half. Okay, so that's what we've done here. So then we have to reverse that at the other end. Once we've got our answer is actually the x minus a half times what our answer is. This is what we got here. Okay, but this is actually twice as much as the actual answer to this question is, because we've divided by a half. Okay, so what we have to do is factor out or divide out a 2. So we're dividing each of these terms in half now, dividing out 2. And so we end up with x squared plus x plus 3. Okay, and then we can recombine this again, 2 times x minus a half, to get 2x minus 1. So 2x minus 1 times x squared plus x plus 3. And then plus 2 is our remainder. Our remainder doesn't change. We don't have to half that one. So our quotient is actually x squared plus x plus 3. And our remainder is actually 2. Now, because of all of this, this can seem a little bit confusing. So sometimes it's a better rule of thumb to use long division for questions like this, where your divisor has a coefficient of x, and just to save synthetic division, just for questions that are x plus or minus something. And you'll save yourself a lot of confusion now that you know both methods. So I would like you to try these questions for homework. We're going to make a little bit of a change to our assignment. I'd like you to do questions 1 to 4, and then questions 7 to 11. And if you come across any questions where you have some coefficient of x plus or minus something, for instance 3x plus 4, just use the method of long division to divide those ones. And just save the method of synthetic division for questions that are simple and straightforward, like x minus 2 types of dividers where there's no coefficient of x.